Alright, just going to do these rest of these problems for you guys so you guys can go back, look at it and whatnot, and kind of study from this. Condensing this log, we have 3 logs. When we condense, we're going to have just 1 log. Looking at the first part, it's in parentheses. We're going to add this, which means we multiply. We have 3 log a, which this can really be written as an exponent. Same thing with this 1/2, it can be written as an exponent. However, 1/2, we like to use the square root. So this, if I want to rewrite it before, log a to the 3rd power plus log square root of b. Since I am adding, I'm going to multiply, so this now becomes log a to the 3rd square root of b. Here we have this 1/3 can also be assigned to this exponent here. It's already squared, c squared, and now there's also a 1/3. 1/3 does mean the cube root. So we have c squared and the cube root of that. Since we are subtracting, that means division. So this becomes log a cubed square root of b divided by the cube root of c squared. Again, it's a little funky having this squared here already, but we would just assign both of these to the exponent. So my final answer is here. Second one, now we're going to expand. So there are 1, 2, 3 variables here, which means I should have 1, 2, 3 logs. Deal with the numerator first. We have the square root of a. Well, we know that it's either a to the 1/2 square root of a. However, we want this 1/2 to be all the way out in the front. So it's 1/2 log a plus 3 log b. Again, the exponent goes in the front. I don't have to have it in parentheses like this one did, but it's fine. And since we have the c in the denominator, minus, so this can be written as power over root 3/4. So it could be 3/4 log c. Okay? Again, pause this, stop it, go back, do whatever you need to do to kind of study from this. If theta is an angle in standard position and point P is 5, -13 is a point on the terminal side of theta, find the value of all 6 trig ratios as fractions and also find the angle of rotation. Alright, so we're going to start with our grid here. 5, -13, 5, -13, it's approximately here. I start with my triangle. Remember, it's a right triangle. I went this way 5, I went down 13. Alright, so first I'm going to have to find the hypotenuse here. So I'm going to use Pythagorean theorem. 5 squared is 25, 13 squared is 169, 189, 194 equals c squared, which means c equals the square root of 194. Okay? It's not a perfect square, so I'm just going to leave it as square root of 194. So my 6 trig ratios, sine, which is opposite over hypotenuse, so we have -13 over the square root of 194. I will rationalize these eventually. Cosine is 5 over the square root of 194. Tangent is opposite, -13 over 15. -13 over 5, sorry. Okay. Our other 3 are the reciprocals, so this is the square root of 194 over -13. Cosine is secant, which is the square root of 194 over 5. And tangent is cotangent, which is 5 over -13. Okay, to simplify this even further, you would have to rationalize these denominators by multiplying these by the square root of 194 over the square root of 194. Okay, I'll let you guys do that on your own. Find the angle of rotation, so you're picking any one of these. I'm going to go with tangent here, and I'm going to find this angle here. So in order to find the angle, I use tangent to the -1 of -13/5. Make sure my calculator's in degree mode. Mode here. It's in degree already. And I'm going to use second tangent of -13 divided by 5. It gives me -68 degrees. So this is -68. It's really 68 degrees because it's a 68 point. Doesn't say what we're rounded to. So if I just put 9.6 here. Now it is -68. However, if I'm finding the angle of rotation, I'm going to find the angle all the way around here. Which means I'm just going to take this, I'm going to add 360 to it. So the angle of rotation is 291 degrees. Again, depending on what he rounded to, it doesn't say here, but we would just have 291 degrees. Again, calculator was in degree mode. Second tangent gave me the angle here. Find the exact value of the following: secant of 13 pi over 6. Now the best way that I would do this is I would turn this into degrees. I multiply it by 180 over pi to turn it from degrees to radians. Sorry, from radians to degrees. Pi's cancel out. I can multiply across. Or I could just 13 divided by 6 times 180. Gives me 390 degrees. Okay, 390 is not in my unit circle. If we went all the way around, that'd be 360. So it's going to be 360 plus another 30. Okay, so if I look for a reference angle of 30 degrees, I'd be okay. Secant deals with cosine. So I'm going to find cosine of 30 here. Exact means it's going to give me a fraction. So if I had my unit circle here, if you guys remember, it's cosine comma sine, x comma y. We want to blow our x's up, so we start with 3. So square root of 3 over 2 is my cosine value. Sine value would be 1/2. So since I want cosine of 30, I only want the x value, square root of 3 over 2. However, I really want secant, which is the reciprocal, 2 over square root of 3. We can't leave this like this. We need to rationalize by multiplying it by square root of 3 over 3, which would be 2 square root of 3 over 3 would be secant. Okay, again, stop this if you need to. I know it's a little bit long video. Reference angle in the following, so 139 degrees. 139 is about right here. If I found a coterminal angle to this, okay, if I had -139 plus 360, gives me 221 degrees. Okay, and the reference angle is here, in which case I would subtract 180 from it. 41. So my reference angle will be 41 degrees here. 830, I'm going to again find the coterminal angle, 830 minus 360, which is 470. I'm going to subtract 360 again. 110 degrees. Again, all I did was subtract 360 from this. 110 would be about right here. Okay, I'm finding the reference angle here. So this is 180, so I'm going to do 180 minus 110, give me a 70 degree reference angle. Okay, Matt places $1,200 in an investment account, earning an annual rate of 4.7% compounded monthly. How much money will Matt have in the account after 10 years? So I'll work algebraically. So I'm going to use A equals P, parentheses 1 plus R over N to the NT. Okay, I'm looking for, this is part A. I'm looking for A. I started with $1,200. R is my interest rate written as a decimal, so 4.7%. I move it to the left 2 places, 0.047. N is number of times it's compounded annually, so since it's monthly, number of times it's compounded per year, it's 12. And we're going for 10 years, so it's 10 times 12 here. The benefit to this is I can plug this whole thing in my calculator here. 1,200, 1 plus 0.047 divided by 12 raised to the, and I recommend to you guys multiplying 10 times 12 before you plug it in here, but it'd be 120. Enter. Okay, so this gives me 1918.23. Since we're dealing with money, we're rounding it to 2 decimal places. And part B, if he invests his money on January 1st, 2019, during which year will his investment double? Okay, so it's a little bit of an extra question here. So his money doubles when it equals $2,400. He starts with $1,200, so a lot of this is the same, but instead of it being 10 times 12, it's actually 12 times t. We don't know how much time has passed. Our goal is to get this part by itself, so I have to divide by 1200 first. You guys have done this plenty of times before. So you get 2 equals, I'm going to simplify this because I like it to be 0.047 divided by 12. I like it to be a little bit easier, 0.0039. I have all the numbers in my calculator. Okay. The variable is in the exponent, so I do have to take log of both sides. We talked about this. Logs don't like exponents, so that's going to get thrown up in the front. So we have log of 2 equals 12t log of this decimal 1.003916. And I'm trying to get t by itself, so what I'm going to do is I'm actually going to divide by 12 log 1.003916. Divide by 12 log 1.003916. Do it all in one step, and we get t equals, so I do log of 2. Okay, be careful how you plug this in. You have to use parentheses with the denominator because we want it to multiply it by 12. So 1.0039166667. Boom. When I press enter, I get my answer, 14.77 years. But it says what year does it happen in. So if we have 2019, and I add, I'm really adding, it happens in that 14th year. If I add 14 here, it's 2033. The year 2033 it happens. It doesn't quite hit 2034, because that would be 15 years. Okay, so the year 2033. And the last question here, Mary. Must have been a similar question here. This is Mary question again. Put $5,000 in an investment account with interest compounded continuously. There's your key word here. Find the approximate annual rate needed for the account to grow to $7,500 after 20 years. So we're actually finding the rate for this one. Okay, so A equals PERT. They want it to grow to 7,500. We start with 5,000. E is just E. And we have R times 20, or let's make it 20R. Okay, first thing is to get this by itself, so we're going to divide by 5,000. 7,500 divided by 5,000, 1.5 equals E to the 20R. Similar to the previous problem, the variable is in the exponent here. Instead of taking log of both sides, since we're dealing with E, I have to take the ln of both sides. Okay, same rules apply. They don't like exponents, they're going to get thrown to the front. ln of 1.5 equals 20R ln of E. Okay, ln of E equals 1, so essentially that cancels out. And in order to get R by itself, we're going to divide by 20. Let's go to our calculator here. ln of 1.5 divided by 20. R equals 0.02027, okay? We need the percentage here. So in order to find out the percentage, I'm going to move the decimal over to the right or multiply by 100. So it's going to be 2%. Okay? Hopefully this helped you guys, and share it as needed, and let me know. All right, thanks guys.